Okay, I'm going to go over question 5 because I think while it's not a great exam question, it's good for your revision for this particular test. Okay, so it says carbonyl compounds, which we know has got C double bond O, so aldehydes and ketones, and alkenes, the C double bond C, both contain double bonds and might be expected to have similar patterns. Okay, while something is similar about them, I suppose, but I wouldn't expect the chemical behavior to be similar. Although there are some similarities in the behavior, there are also significant differences between the properties. Okay, so whenever I see this word properties, which obviously comes up really frequently, I'm always thinking, is it going to ask me about chemical or physical? Make sure I'm not going to talk about the wrong ones. Use ideas about bonding. Okay, so I have to talk about bonding in the alkenes and carbonyl to discuss the similarities and differences. It wants me to mention similarities and differences, and then here we go, it's saying chemical properties. I'm not going to mention physical properties of the carbonyl compounds and alkenes. So immediately when I see chemical, I'm thinking something to do with breaking bonds possibly, or the stronger the bonds, the harder it is to break, the less reactive it will be. And something to do with the polarity or electronegativity of the atoms involved there as well. Okay, so yeah, first things first, in my mind, I'm going to think of an example of two similar things. And actually, I've kind of gone for, this ketone and this alkene. I wouldn't draw them on my exam paper, but this is what I'd be imagining in my head. Okay, so I'm looking at them and thinking, what's the same? Well, for starters, they both got double bonds. So that might be mark number 1 for me. They've both got double bonds. Are there any other similarities? Well, anything with a double bonds kind of often undergoes, so mark number 2, addition reactions. Okay, so I might mention that we've got they're both going to undergo addition reactions. So here we go, I've got 2 similarities, and now I'm going to try and think of kind of 5 or some more differences possibly. Okay, talk about differences for the rest of the marks. Okay, for starters then, if we look at this carbonyl group, we've got a disparity in electronegativity. So we've got this oxygen who's going to be stealing kind of an unfair amount of these electrons because it's electronegative. So it's going to have this delta negative. Okay, and this carbon therefore is going to be left as delta positive. So therefore this positive area will attract negative things. Okay, so it's going to attract a nucleophile, this area is. And what nucleophiles do we know about? We know about this H- that comes from sodium borohydrate, and we know about the cyanide ion. Okay, so that's the kind of thing that this will react with, and I would certainly remember these mechanisms as well, okay, for your revision. So I wouldn't draw them in here, but make sure that you learn the mechanisms for these 2 things reacting with this compound. Okay, so that's going to attract a nucleophile. But if we have a little look over here, there's no disparity in electronegativity. Carbon and hydrogen both have very similar electronegativity, so we're not going to get areas of kind of positive or negative because of that. What we do have, though, is an area of high density of electrons here around this double bond, okay, because we've got the sigma bond and then we've got the pi bond, so there's extra electrons in there. The high density of electrons means it's going to attract something that's going to be positive, okay, so something positive is going to be an electrophile. So if something is positive, it's going to be attracted to electrons, so electrophile. So we've got the H plus, or we've got the delta positive, so those bromines in that mechanism that you need to know about. Okay, so these things will undergo electrophilic addition, while this will undergo nucleophilic addition. So that could be a difference, isn't it? And I think just by talking about that, the fact that this is nucleophilic and this is electrophilic, and then actually mentioning some things that will react, I think looking at the marking scheme, then that gives you plenty of marks to get those 6 marks. So if we have a little look here, I've both take part in addition. Okay, so we've said potentially what they get added with already. Okay, I mentioned this as well. Okay, we could have mentioned that the pi bond breaks for the addition. Okay, I did when I had a little go. I kind of mentioned that in mine before. Okay, we did mention the electrophiles then. High electron density there, mentioned that as well. Nucleophiles mentioned as well. We've got this part of the bonding was also mentioned. As you can see, there's plenty of marks already just from what I talked about there. They've got sort of ticks, and then there's possibly other things down here as well that are more tenuous. In the marking scheme down here, actually, I noticed that it says the pi bond is weak in alkenes. Okay, sorry, I thought it was wrong, but actually that's fine. Okay, so you could have said that as well, but we shouldn't need it, just from those marks above. Okay.